Let's look at a few examples of parabolas in their standard conic form. And we want to be able to maybe write the equation for a given graph, or if we're given the equation, we might want to sketch its graph. And then we want to also be able to identify the key characteristics. So that would be the vertex, the focus, the directrix, the focal diameter, and then maybe the axis of symmetry. Okay, so those few characteristics there that we want to be able to identify. So for our first example here, we have a parabola given by a graph, and the graph is opening to the left. So this means the graph has a horizontal orientation. Okay, so if we're thinking about writing the equation of the graph, then a parabola oriented horizontally is going to have a y squared term. Okay, so we might think of this as y squared equals 4p times x. But that will only work if the graph has its vertex at the origin. If we look at the graph we're given, the vertex is not at the origin. The vertex is actually at the coordinate 2, -1. So we can't use just y squared equals 4px. We have to account for the fact that it's been shifted. And so the standard conic equation for a parabola that has a horizontal orientation is going to be the quantity y minus k squared equals 4p times the quantity x minus h. The h value represents the x coordinate of the vertex, and the k value represents the y coordinate of the vertex. And we already actually know our vertex. So we already kind of observed this. The vertex is at the point 2, -1. So we could actually go ahead and put the 2 and the -1 in our equation, and we'll see what it starts to look like. Okay. So for the y component, so for our equation, we're going to have y minus a -1, and that whole quantity squared, and that equals 4p times x minus 2. And we could simplify that a little bit, because if you take y minus a -1, it's actually going to become y plus 1. So y plus 1 squared equals 4p times the quantity x minus 2. Okay, and as we look at those two expressions, x minus 2 means the graph shifted in positive x direction a distance of 2, which is where the point 2, -1 is. And the y plus 1, we're going to go in the opposite direction. So y plus 1 means the graph shifted in the negative direction a distance of 1. And again, that's where we see that -1 y value in our vertex. So our equation right now is y plus 1 quantity squared equals 4p times x minus 2. To finish our equation, we need to figure out the value for p and then plug it into the equation. To figure out p, remember p describes or gives us a relationship for the distance from the vertex to the focus or from the vertex to the directrix. Well, unfortunately, we don't know where the focus or the directrix are on this graph, so we can't use those relationships. However, looking at the graph, it does look like we can kind of identify a few points on the graph where specific points where the curve of the parabola actually crosses those points. Okay, so for instance, it looks very clearly. Again, we're making sort of an assumption here, but that's okay for today. It does look like the graph passes through the y-intercept, so the coordinate of 0, 1. Okay, there are others that we could pick through. It looks like it also passes through another y-intercept of 0, -3. And there might be a few other points that we could kind of observe, but that just gives us two that we could work with. And you don't need both of them, really just one is all we need. So let's use the 0, 1. Okay, we could do the other one as well, but so let's take that y-intercept of 0, 1, and so we're going to plug 0 into our standard equation. We're going to plug 0 in for x and 1 in for y. So we're going to have 1 plus 1 quantity squared equals 4 times p times the quantity 0 minus 2. Remember, 0 was the x-coordinate, 1 was the y-coordinate. If we simplify this, so 1 plus 1 is 2. So we're going to have 2 squared equals 4p times a negative 2. 2 squared is 4. And then 4 times the negative 2 is a negative 8. So 4 equals a negative 8p. And if we divide both sides by negative 8, we get that p is a negative 1/2. Okay, so because the p-value is negative, that tells me that the graph opens in the negative direction. Since it's horizontal and in the negative direction, that would be to the left, which is the direction that we see the graph opening. Okay, so that does correspond. So it looks like we're going in the right direction here. Okay, so now that we know P, we can finish the problem. We can write out what the equation looks like, and we can figure out the other key components of our graph. So to finish the equation, let's just take that p-value of -1/2 and plug it into our equation. So we're going to have y plus 1 squared is equal to 4 times a -1/2 times the quantity x minus 2. Okay, so we're using that equation there. Y plus 1 quantity squared equals 4p times x minus 2. And so again, we have y plus 1 quantity squared equals 4 times the -1/2 times the quantity x minus 2. All we got to do is simplify the 4 and the 1/2. So we're going to be left with y plus 1 squared is going to be equal to a -2 times x minus 2. So that is the standard equation, standard conic equation for this parabola. All right, the other pieces that we need, we already know the vertex. We want to find the focus. We want to find the directrix. We want to find the focal diameter. And we want to find, let's go ahead and do the axis of symmetry. Okay, and let's actually start with the axis of symmetry. Okay, the axis of symmetry is the line that you could draw directly through the middle of the parabola. So since we have a parabola that is oriented horizontally, we're going to have a horizontal axis of symmetry. It also has to pass through the vertex. So since the vertex is at 2, -1, we have to have a horizontal line along y equals a -1. So our axis of symmetry is just the equation y equals a -1. So it's the horizontal line, y equals -1. To find the focus and the directrix, remember the focus and the directrix are the same distance away from the vertex. That distance is p. Well, we know p is a half. So how far is it from the vertex to the focus? A half. Okay. And remember, the parabola has to open around the focus away from the directrix. So if it's opening around the focus, that means the focus has to be a half of a unit to the left of the vertex. If the vertex is at 2, -1, what's half of a unit to the left of that? It would be at 1.5, comma, -1. Or you could rewrite that as 3/2, -1. Okay, so that's where our focus is at. The directrix is the same distance away, but in the opposite direction. So we're going to travel 1/2 of a unit to the right of the vertex. If the vertex is at 2, -1, then that means the directrix is at x equals 2.5. Or you could rewrite that as x equals 5/2. Or you could do it as a decimal, 2.5. So again, the distance from the vertex to the focus has to be a half. and the distance from the vertex to the directrix also has to be a half, because that's our p-value is a half. The parabola curves away from the directrix around the focus. So since it's curving to the left, the directrix has to be to the right, and the focus has to be in the middle, inside. It has to be to the left of the vertex. Okay. All right, the last piece that we need is the focal diameter. The focal diameter is the width of the parabola with a diameter passing through the focus. And it turns out that this focal diameter value is equal to the magnitude or the absolute value of the 4p. And so in this case, we already found that the 4p was equal to a -2. And so if you just take the absolute value, we don't need the negative in here. We know that the focal diameter is going to have a length of 2. So that means the parabola is 2 units wide if you were to draw a diameter from one side to the other passing through the focus. Okay. Which actually does happen. If you look at our parabola there, it's 2 units from the top edge to the bottom edge passing through the focus there. All right, let's try another example. This time we're given some information about the parabola. We're told where the vertex and the focus are, and we want to go ahead and sketch its graph and write its standard equation. Okay, so let's try and start by sketching a graph. And again, when we sketch a graph, a sketch is just that. It's not a perfect drawing. It's just kind of a rough drawing. So for our vertex, we're told the vertex is at -1, 5. So we're going to go 1 unit to the left and 5 units up, and that's going to be my vertex. And then I'm also told the focus is at -1, 3. So we're also going to the left 1 unit and up, but this time only up 3 units. So our focus is at -1, 3, and the vertex is at -1, 5. So what's the orientation of our parabola? Which direction does it open? Remember, it has to pass through the vertex. It curves away from the directrix and around the focus. And both the focus and the vertex have to be on the axis of symmetry. So if I drew sort of a vertical line, it passing through both the vertex and the focus, that has to be the axis of symmetry. Okay, so we have a vertical parabola. And since it has to go through the vertex and around the focus, this parabola is going to have to open down. Okay, so we have a vertical parabola opening down. And so a vertical parabola is going to have the form x squared equals 4py. That's if we're centered at the origin, but we're not at the origin. We're at -1, 5. So the standard equation, if we are not centered at the origin, or if we're not, our vertex is not at the origin, is the quantity x minus h squared equals 4p times the quantity y minus k. And the h and the k value are our vertex. So again, we already know our vertex. It is at -1, 5. And we know the focus is at -1, 3. Okay. So we could already go ahead and write part of this equation. We could plug in a -1 for the h and a 5 for the k. So we're going to have the quantity x plus 1 squared, and it's plus 1 because it's technically minus a -1. X plus 1 quantity squared equals 4p times the quantity y minus 5. Okay, because again, the -1 and the 5 are the x and the y coordinates, respectively, of the vertex. Define p. Once we can find p, then we can finish writing the equation. Remember, p is the distance from the focus down to, from the vertex to where the focus is at. So if the vertex is 5 and the focus is 2, the distance from 5 to 3 is a distance of 2. So that means p has to be 2. Now, technically, because the focus is below the vertex, the graph opens down, we're actually going to say it's negative. So P is equal to a -2. Again, it's negative because the graph opens down. So let me take that -2, put it in my equation, and then we'll simplify. So we have x plus 1 quantity squared equals 4 times the -2 times the quantity y minus 5. And so our final equation is going to be x plus 1 quantity squared equals a -8 times the quantity y minus 5. So again, that's our standard equation for this conic. The -8, again, tells me the graph opens in the negative direction. And because it's an x that's being squared, x is our squared variable, it's going to be a vertical graph, so it's going to open down. Okay, let's do our directrix. And then our focal diameter. And we can go ahead and do our axis of symmetry, which we've already kind of observed here. Axis of symmetry. Okay, so the directrix is, since this is a vertical parabola, we're going to have a horizontal directrix. And the distance from the directrix to the vertex is also the same as the distance from the focus to the directrix. So if the focus is 2 units away from the vertex, then the directrix is also going to be 2 units away from the vertex. So if the focus is at -1, 3, the vertex is at -1, 5, that means the directrix has to be the horizontal line at 7. So the directrix is going to be the horizontal line, y is equal to 7. Okay, because it's 2 units above the vertex, and the focus is 2 units below the vertex. Our axis of symmetry was the vertical line passing through the vertex and the focus, which means the axis of symmetry is x equals a -1. And the focal diameter, remember the focal diameter is the absolute value of the 4p, which in this case, that 4p is a -8, so the absolute value of a -8 is just an 8. So again, that means the graph is going to be 8 units wide from left to right side of the parabola if you measured it as a diameter through the focus. All right, let's look at one more example. This time we're given the equation of the parabola in sort of an expanded form. Okay, so it's not factored in our standard form that we look at. It's more of a general equation. It's not factored for us, so we're going to need to do a little bit of algebra to get it in our standard form. Once we have it in standard form, we can then go ahead and identify what the vertex is. We can figure out the value of P, which lets us find the focus and the directrix and the focal diameter, and then we can sketch its graph. Okay, so the equation that we have is x squared plus 6x minus 8y plus 17 equals 0. So because I have an x squared, I know this equation is going to have some form similar to x squared is equal to 4py. Again, that's assuming it's at the origin. It could be shifted, so you might have like x minus h quantity squared is equal to 4p times y minus k. So I need to rewrite this generalized equation in that standard form. And to do that, we're going to have to isolate our variables, and then we're going to have to use some completing the square. So because the x minus h squared term is on the left side of our standard equation, I'm going to leave any x variables, any x terms on the left side, and I'm going to move the y and the constant to the right side. So let me rewrite this equation as x squared plus 6x, and that's going to now equal a positive 8y minus 17. And again, I'm just trying to organize the variables so that I can eventually match it up to this equation. I want the x's on the left, the y's on the right, because it's x squared equals 4py. So on the left side, I have x squared plus 6x. In order to get that factored, I need to complete the square. So completing the square means you're going to have x squared plus 6x plus some value. And to figure out that value, we're going to take the number in front of x. So in this case, that's a 6. We're going to take that 6, we're going to divide it by 2, and then we're going to square it. So 6 divided by 2 is a 3, and then 3 squared is 9. So I'm going to have x squared plus 6x plus 9, and that's going to equal 8y minus 17. But I just added a 9 to the left side, which means I also have to add a 9 on the right side. Okay, so I have x squared plus 6x plus 9 equals 8y minus 17 plus 9. Okay, on the left side, x squared plus 6x plus 9, that can be factored as x plus 3 quantity squared. So it's a perfect square here. And then on the right side, we'll have 8y, and I can go ahead and combine a negative 17 with a positive 9, and that will give us a minus 8. Last little step here is we want to factor the right side as well. And both terms, if you notice, both terms have an 8 in them, so let's factor that 8 out. So we're going to have x plus 3 quantity squared equals 8 times y minus 1. And that's going to be the standard equation for our conic that we wanted. Now, from that equation, we want to figure out what is the vertex, what is the focus, what is the directrix, and what is our focal diameter. Okay, so remember the vertex, that is our h and our k value. The h is the value that's in the parentheses with the x, and you flip the sign. So if it's a plus 3, it's going to be a minus 3. And the k value is the number with y. So since it's x plus 3, the vertex is going to have an x coordinate of a negative 3. And since it's y minus 1, the vertex has a positive 1. So remember our shifts. When they're inside parentheses, you do the opposite sign. So x plus 3 would be a negative 3. Y minus 1 would be a positive. So our vertex is the coordinate negative 3, comma 1. To find the focus and the directrix, we need to figure out the value of p. Well, remember the 4p in our equation, in our standard equation, is going to correspond to the 8 that we have in our specific equation here. So we have 4p has to equal that 8, which means p has to be 2. And it's a positive 2 because it's a positive 8. So the graph has to open in the positive direction. Okay, and since it's an x that's being squared, I know it has to open vertically. It's a positive x squared, so I know it has to open up. So that means if the graph opens upwards, the focus has to be above the vertex. The directrix will be below the vertex. And the distance between each of those is the value of p. So since p is 2, I know the focus has to be 2 units above the vertex. And if the vertex is at negative 3, 1, 2 units above negative 3, 1 would be negative 3, 3. Okay, so it's just 2 units above the vertex. The directrix has to be 2 units below the vertex. Again, that's because the graph opens upwards. The directrix goes in the opposite direction. So what is 2 units below y equals 1? Well, that would be a negative 1. So the directrix is going to be y equals a negative 1. And again, the reason I'm using the y values here, I'm adjusting the y values, is because I know the parabola has to open vertically. It has to open up because the p-value is positive. So if it's opening up, the focus has to be above the vertex and the directrix has to be below the vertex. Okay, so I don't need to adjust. There's no horizontal movement. It's all vertical. Okay, so the focus is 2 units above the vertex. The directrix is 2 units below the vertex. Okay. So let's actually plot those points on here just so we can kind of see that connection here. I know the vertex is at -3, 1, and I know the focus has to be 2 units above that, which is at -3, 3. And I know the directrix has to be the line y equals -1. Okay. So again, just looking at the graph, the distance from our vertex to our focus is a distance of 2, and the distance from our vertex down to our directrix is also a distance of 2. And that's what it's supposed to be because our p-value is 2. Right? And I know, again, the focus has to be above it. The other piece of information that might help us finish this graph is figuring out the focal diameter. Remember, the focal diameter is the absolute value of the 4p, which in this case, the 4p is an 8, and the absolute value of an 8 is an 8. So the graph has to be 8 units wide as you pass through the focus. So that means from the focus to the left is a distance of 4, half that distance. And the distance from the focus to the right side of the graph is also 4, right? Because a total distance of 8 means 4 to the left and 4 to the right. So if we look at our focus and we travel 4 units to the right, we're going to be over here to +1. And if we go 4 units to the left, 1, 2, 3, 4, we're actually going to be a little off the graph there, but we'll put it in there. And so if we connect our vertex and draw a curve through those graphs, through those 2 points on the left and the right side, we're going to have a graph that looks kind of like that. Okay. So again, it should open upwards, and it should pass through the vertex at -3, 1. Its focus is at -3, 3. The directrix is at y equals a -1. And it's 8 units wide through that focal diameter. So through here, that is 8 units wide. All right. If we also wanted to figure out where the axis of symmetry is, that's the vertical line that passes through the focus and the vertex. And so that's the line x is equal to a -3.